Hello and welcome to Young Minds versus Physics. Yes, in the previous video, we have seen how to add vectors and how to subtract the vectors. See, when the case is like when one vector is perpendicular to the other one, okay, as the example what we have taken previously. Now, from the laws, you can say from the basic knowledge, this is the resultant, and the resultant is 5 root 2. And the resultant here is 5 root 2 meters. Yes, 5 root 2 meters. Now, suppose if this angle is not 90 degrees, if this is not 90 degrees, and if something like somewhere here or like this, the triangle is formed like with a different angle. That means the angle between two vectors is not 90, not 0, not 180. Yeah, why am I specifying about 0 and 180 degrees? If 0 means both the vectors are acting in the same direction, either parallelly or collinearly. Is it not? Either parallelly or collinearly. And both the vectors will get added up. Is it not? A bar plus B bar, where the modulus of A bar, if it is A, then the resultant is equal to A plus B. If it is 0. If it is 180, not an issue. It is as though like you have stretched both your hands on opposite directions like this. So 180 degrees. Use your common sense, right? Suppose this is of 5 Newton, this is of 3 Newton, and very easily you can say that the resultant will be here, like with a magnitude of 2 Newtons, right? So that means if the angle is 90 or 0 or 180, definitely we will be able to add and find the resultant of the vectors from the basic geometrical conditions, just applying all that, right? But if the angle is not going to be any one of these, and if it is going to be somewhat different, then how are we going to find out the resultant? So let's see that. So that is the analytical approach to add or subtract vectors. Right, now let's discuss about addition. Now, see, this is the condition what I wanted, what I was saying about, where here the angle is neither 0 nor 180 nor 90. So it is something like an obtuse angle here, you can see from the picture. If this is the case, what are you going to do? How are you going to determine the resultant magnitude and direction? Yes, now let us recollect the basic trigonometric relations or ratios. From that, you can easily come out of the situation and you can start solving the problems. Okay, here we go with. See, as I said, angle between two vectors means it is the angle between their directions. Here are the two vectors A bar and B bar. So from directly when you view this, you may feel that this is the angle. No, absolutely not. Why? Because the condition, simple condition what we discussed is that both the arrow marks or both the direction should be away from the point of application. Right here, that is from the point where both the vectors intersect. Right, so here, so if you observe these two arrows, see one is approaching and the other is moving away or the receding. So therefore you can see that angle between these two vectors can be only obtained when you extend this This is the actual vector. This is the direction of the vector. And with this direction, now the direction of this vector is making an angle theta. That means these two are the rays between which angle is given. And now, in order to find out the resultant, just now drop a perpendicular from the terminal point of the second vector on to the first vector. See, beautifully it is dropped. Right. Now, if you observe the triangle, we have two right-angled triangles here. One being OMB and the other being AMB. And now, from the magnitude of the vectors, we have seen already that modulus of A bar can simply be written as A, or size of the line segment which is representing the vector, that is OA. Right, magnitude of B bar, that is modulus of B bar, is equal to the size of the line segment representing it, which is AB, which is equal to B. Right, so now we are done with, now we know the value of OA, we know the value of AB, that is A and B respectively. And now from the triangle AMB, which triangle am I taking? This triangle. Now I know this value and theta. I know hypotenuse and theta. Right, now it is very easy to find out the adjacent side and opposite sides. Yes, you are right. You are on the way. Adjacent side means you are going with cos, and the opposite side of this given angle means you are going with sine, the trigonometric ratios. Yes, you are absolutely right. The adjacent side by hypotenuse gives you the cos theta value. Thus, this side, this one, AM, is equal to AB cos theta. But what is AB? It is B. Now, therefore, B cos theta. Absolutely. Now, we are done with this. Now, you know the value of this. This is B cos theta. And similarly, if you go with the opposite one, yes, you're right. It is B sin theta. B sin theta. Perfect. Now we know the value of this, and this one also we know because OA is equal to A. So we know the values of these two sides of this bigger right angle triangle which is defined between OM and B. Yes, absolutely right. So now if you wanted, right, this particular side, it is OA plus AM, that is A plus B cos theta. And if you want this side, this is B sin theta. Yes, now it is very easy for us to find out this hypotenuse because you have the other two sides of the right angle triangle. Yes, applying Pythagoras theorem. Yes. Now, to find out the magnitude, we are going with the basic substitutions, OB being the resultant. So, OB square is equal to OM square plus BM square, where OM is OA plus AM, where OA is AA plus B cos theta, substituting and then further simplifying. You can look at the simplification format, right? So, in place of OA, are substituting A. In place of AM, we got it to be B cos theta already, right? And BM, we got it to be B sin theta. So, substituting all the respective values, you got R square. If you imagine mod R bar is equal to R, then R square is equal to A square plus B square plus 2AB cos theta, which is, of course, you will be seeing it in parallelogram law of vectors. Beautiful. See, I didn't draw any parallelogram here. Did you observe that? Yes, there is no need for you to draw the parallelogram here when the problem is given like this. Right. So now how to understand parallelogram law of vectors? Now let's go back and see the same diagram, how we are going to convert it into a parallelogram. Yes, this is your diagram, right? So where A bar and B bar are given like this. Now if you just draw a line which is a parallel to B bar, right? So let me draw it exactly parallel to B bar. Yes, this is the B bar. Now opposite to this, parallel to the other one, this is A bar. So it is the same parallelogram what you will be studying in your NCRT books or the state board books. Yes, now if two vectors are represented by the two adjacent sides of a parallelogram drawn from a point, can you see that now here? Yes. Right. Now, then the resultant is represented by the diagonal of that parallelogram passing through the same point in direction and magnitude. See the beauty of physics here. We didn't consider the parallelogram at all. Just we have taken like from our fundamental understanding of vectors. Just we took a vector from O to A and A to B, and you know that from addition of vectors OB is going to be the resultant. That's all. And from there we could find out the R value to be equal to square root of A square plus B square plus 2AB cos theta. And now we are converting this diagram into a parallelogram where beautifully that is there in your textbooks, right? So now here I repeat that one again. If the two adjacent, if two vectors are represented by two adjacent sides of a parallelogram in direction and magnitude, then their resultant is represented by the hypotenuse drawn through the same point. Beautiful, right? Yes. Now just see how we could come to the conclusion here. R is equal to square root of A square plus B square plus 2AB cos theta. And now coming to the part of direction. Now tan alpha. Like how are we going to find what is this alpha? From where did we get this alpha? Now let us see from where we got this alpha. Yes, if you observe the diagram here, angle between these two vectors is theta. Yes, angle between these two vectors is theta, undoubtedly. Now, angle made by the resultant, with the first vector A bar. With the first vector A bar, if we imagine it to be alpha, if we imagine it to be alpha, now you all know mathematics, right? From the right angle triangle, tan alpha is equal to opposite side by adjacent side. Where from this triangle OMB, what is the opposite side? B sine theta. What is the adjacent side? Already we determined it, right? A plus B cos theta. The whole thing is adjacent side. That is A plus B cos theta. Yeah, here we go with tan alpha is equal to Bm by Om. That is B sin theta by Oa plus Am. That is A plus B cos theta. Wow, we got it. Tan alpha is equal to B sin theta by A plus B cos theta. These two are the most important tools. These two are the most important tools in solving problems based on parallelogram law of vectors. You can also take it as a triangle law. So there is nothing to be worried because here the two given vectors and the resultant are forming a triangle. Right, children? Yes. So now the same concept is extended as parallelogram law of vectors. Beautiful. Yes. Yeah, here if we observe the diagram again, A bar and B bar are two given vectors right, where the angle between them is theta and the resultant is a bar plus b bar, which is making an angle alpha. This is what your parallelogram states. Okay, done. We are done with addition. Now what about subtraction? Is your parallelogram law going to help you in finding the subtraction also? Yes, here we go with. Right, fantastic. So the same parallelogram. The same parallelogram law of vector addition can be used for subtraction also. Now, what is the basic principle of subtraction? Yes, from the head of the first vector, you are going to draw the negative vector of the second one. This is the second vector. Draw the negative vector, or else you want to draw here, no problem. So draw a negative vector here. This is a minus b bar. Now you have again another parallelogram. Wow, wow, wow. This is another parallelogram where the given vectors are a bar, and then here you have it to be minus b bar, where magnitude is going to be the same, my dear. It is b, it is a. Young minds, my dear young minds. You know already that negative vector means having same magnitude, but just simply direction is opposite to the given one. That's all. Now use your common sense as ever, right? See, here we are like applying forces in two directions. Then this is going to be the resultant direction. Yes, the same. Of course, parallelogram law also states the same thing. If two vectors are represented by two adjacent sides of a parallelogram taken in order in direction and magnitude, then, right, the resultant is represented. Here, what is the resultant here? Is it plus? No, it is a bar minus b bar. A bar minus b bar. So what are you going to find out? Your R bar is modulus of a bar minus b bar, and the angle between the two given vectors is, here it is theta, here it is 180 minus theta. Is that clear? Right. So therefore substitute in place of theta 180 minus theta. That's all. Right. So you have modulus of a bar plus b bar is equal to a square plus b square plus 2ab cos theta under root. Now in place of theta you are going to get 180 minus theta, and in place of mod of a bar plus b bar you are going to get it as mod of a bar minus b bar. Beautiful concept. Right, so a square plus b square plus 2ab cos of 180 minus theta. What is cos of 180 minus theta? Come on, it's minus cos theta. So thus we will be getting it as a square plus b square minus 2ab cos theta under root is mod of a bar minus b bar. Wow, and this is of course parallelogram law of vectors. Right? Yes, now coming to the direction. Here we go with the same definition. How we have defined here the direction of the resultant with respect to the first vector. Yes, we are doing the same here also. Here also the same thing. Here in this case, a bar is the first vector, minus b bar is the second vector, and beta is the angle made by the resultant a bar minus b bar with a bar. Come on, young minds. Now in place of theta, you are going to substitute 180 minus theta. In place of tan alpha, you are going to take tan beta. If you just want to go by, yes, formula, or you want to go by concept, yeah, the same thing. Drop a perpendicular and make it a right angle triangle, extend a bar, and you can see that this is going to be the opposite side and this is going to be the adjacent side. Thus you will be getting it to be sine of 180 minus theta into b to be the opposite side, and a plus b cos of 180 minus theta as the adjacent side. Clear? So now sine of 180 minus theta, sine theta, cos of 180 minus theta minus cos theta. Thus we got tan beta is equal to b sine theta by a minus b cos theta. Right? This is from what you say parallelogram law of addition. Now I say it is parallelogram law of subtraction. Yes. You can go like that. Chalo, fatafat, let us play the concept under different cases. Yeah, first one, vectors in same direction. A bar, B bar in the same direction. The angle between them is 0. And cos 0 is 1. Substitute. That's all. A square plus B square plus 2AB. This becomes 1. So A plus B whole square under root. That is R is equal to A plus B. In this particular case, maybe they are parallel to each other or they can be collinear. Right? And here what you say is this is the resultant in the same direction. Use your common sense. Here, common sense versus physics. Whatever you observe, the same physics is going to give you out. Right. Now, if A is equal to B, wow, R is equal to 2A or 2B. And now the direction of the resultant with respect to the first vector, what is that? 0. Angle is 0. So tan alpha is equal to B sin 0 by A plus B cos 0. If you go by formula, sin 0 is 0, 0 by something which is a non-zero value is equal to 0. Right. So it can be 0 or 180 because tan alpha here can be 0 means alpha can be 0 or 180. But here there is no point of talking about 180 degrees because if two forces are acting in the same direction, their resultant can never be in opposite direction. Right? Yes. So now the next one. Vectors in opposite direction. Yes. Right, 180 degrees, substitute theta is equal to 180. You can see, right, by substituting what you'll get? A square plus B square cos 180, right, minus 1. What is cos 180? Minus 1. So it will become minus 2AB. That means A minus B whole square under root. So what is R is equal to? R is equal to under root A minus B whole square. Now you can't decide whether it is A minus B or B minus A. Yes, is it not? It can be A minus B or it can be B minus A. Thus I am writing it as just A difference B. Just A difference B. That is what just we have seen in the beginning of this video. 5 newtons here, 3 newtons here. Then the resultant is 5 minus 3. It is 2 newtons. Right, and this is when A is greater than B, it is A minus B, or B is greater than A, B minus A, whichever is dominating. In that direction the resultant will be, and thus the angle made by the resultant with the first vector may change here. Because if A bar is dominant, then the angle is going to be 0. If B bar is a dominant vector, then the direction of the resultant will be in the direction of B bar. So therefore, now here it is going to be 180 degrees. Right? And A is equal to B, balance. They'll get cancel, annul each other, and the resultant is going to be 0. Right? Vectors are mutually perpendicular. Yes, A square plus B square under root. You can do it directly applying Pythagoras theorem, or you can substitute it in your magnitude formula. And tan alpha is equal to B sin 90 by A plus B cos 90. Sin 90 is 1, cos 90 is 0. This becomes 0, it is B by A. So tan alpha is equal to B by A, or the angle made by the resultant is tan inverse of B by A. It is tan inverse of B by A, and if A is equal to B, it can be A root 2 or B root 2, and alpha is 45 degrees. That is, whenever these two are of equal magnitude in the cases other than the above two cases, always resultant bisects the angle between the two given vectors. This is very, very important conclusion, my dear young minds. Yes. Right, now the other case is when A is equal to B. We are going to generalize it. Right? So now when A is equal, just now we said, right, the angle between the two vectors will be bisected by the resultant, or rather the resultant exactly acts midway between the two given vectors, right? So this is what we are going to prove. Now use all your trigonometric principles. So R is equal to, since A is equal to B, I am taking it as A square plus B is in place of B square. A square 2AB cos theta. Now 2A square plus 2A square cos theta, taking 2A square common, you got 1 plus cos theta. And you have the relationship here that cos 2 theta is equal to, what is cos 2 theta is equal to? 2 cos square theta minus 1. 2 cos square theta minus 1. But here what do you observe? In place of 2 theta, you have theta. So when in place of 2 theta, if you have theta, in place of theta, you'll get theta by 2. That is the same here. 2 cos square theta by 2 minus 1. So in place of cos theta, you are writing it as 2 cos square theta by 2 minus 1. 1 and 1 minus 1 will get cancelled. You are left with 2a square into 2 cos square theta by 2. 2 into 2 will become 2 square. A square already existing. Cos square theta. So R is equal to 2a cos theta by 2. Directly, this is very, very important relationship. While solving problems, this is going to help you a lot. Right? When A is equal to B, that means when the two given vectors are of equal magnitude, absolutely resultant is 2A cos theta by 2. Right? Where theta being the angle between? Yes, the given vectors. Right? Now, tan alpha is equal to A sin theta by A plus A cos theta. Taking A common and cancelling, you got it to be sin theta by 1 plus cos theta. What is sin theta? 2 sin theta by 2 into cos theta by 2. And already we have seen 1 plus cos theta is equal to 2 cos square theta by 2. I am substituting it here. Right? So 1 cos theta by 2 cos theta by 2. 2 will get cancelled. You are left with sin theta by 2 by cos theta by 2, that is tan theta by 2. Alpha is equal to, therefore, theta by 2. Yes, that means the angle made by the resultant is exactly half the angle between the two vectors. Therefore, the resultant bisects the angle between the two given vectors. When, dear? My dear young minds, this is only when A is equal to B. Only when the magnitudes of the two given vectors are equal. Remember, don't get confused with A bar is equal to B bar and A is equal to B. Right? If A bar is equal to B bar, then absolutely two vectors are having same magnitude and same direction.